Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about multiplexer and demultiplexer in combination circuits. So these are all the slides we are going to see in this video. Introduction. A multiplexer is the term itself. We know that multiple number of input has been given and we can get the only one output. So it is known as a multiplexer. And demultiplexer means it is the same opposite of multiplexer. One input is given and many number of output has been taken based on the n number of selections. So here the selections has been done based on the input variables. One select line is two inputs and two select lines are four and three select lines are eight bits. Like this we can able to select. Let me see how this selection line will be happen, and it can be taken as input signals. Two input signal only one output, and four input signal one output, eight input signal one output. So here the values has been taken and it can be calculated based on the n equal to 2 power n values. So here n is a variable in which we can apply n equal to 3 means it is created as a 8. So 8 is to 1 multiplex has been taken. So here the multiplexer based on n is to 1. So n is n number of time as calculated. For example, n equal to 8 means 8 is to 1. So input is 8 and output is 1. So here they are taken as four variables. So 4 is to 1. So that's why they are taking as D0, D1, D2, D3 as a four input variables. And for enable input has been fetched for both input signals 0 or 1, so that E can be calculated up to zeros and ones, and the selection lines also acted in this input terminals. So here the selector line is Sn minus 1 for two input variables. S0 and S1 has been taken. So the common mode of multiplexer like D0, D1, D2, D3 and S0, S1 is the additional selection line, and only one output has been taken. So let me see how this 4 is to 1 has been taken. So the 4 is to 1 has been taken based on the input signals because we are giving four inputs D0, D1, D2, D3. So the corresponding output has been taken based on the gates. So here I am just taking a NOT gate and AND gate. So NOT gate is used for selection lines S0 and S1. So before giving to the NOT gate, the value will be 1, and after giving the NOT gate, the value will be 0. So the value can be taken here as S0, S0 bar. So S0 is not giving the input to the NOT gate. So after giving the NOT gate, the value will be S0 bar. So like this, S1 and S1 bar will be here, and the default value will be E. So E is the line will be given to all the values. So after giving all the values, then we can able to take the output. For example, D0 means the value is S1 bar and S0 bar. So the value, same value will be given in the table. For example, 0 0 means D0 bar. So 0 already told that 0 means bar. So S0 bar, S1 bar. So S 0 0 S0 bar, S0 bar, S1 bar. Then the term will be 0. Then it will be considered as D0. So 0 means there is a nothing value. So like this, all the value will be calculated based on the input signal D1, D2, D3 up to 4 values. So in demultiplexer, the same opposite ratio of multiplexer, like only one input has been given and four output has been generated. For 4 is to 1 multiplexer, here they are given only one output, 2 power n. So n is 2, so the 4 output value has been generated. So here I am just giving only one input, only one input is dn. So dn is given for all the gate values. And moreover, we can able to take the selection line is common. So the selection line is has been taken as S0 and S1. After giving the NOT gate, then it will be considered as a S0 bar, and moreover it will be implemented for S1 bar also. So all the values will be given in this NOT gate and gate, and then the final value will be taken. So the values are notified here. So the enable is 0. So sometime if the value is 0 means, and then it will be it automatically calculated. So it will be repeated up to the values which will be up to the end of the table. So here the S0 and S1 will be 0 or 1. It may be 0 0 or 0 1, and it may be 0 1 or 1 0. Like this, four combinations, and the zero values will be repeated up to eight times. So the corresponding D0 value, D1, D2, D3, the concern S0 bar S1 will be placed here. Suppose if it is D1 1 means then output value will be 1 1. So then the same value will be fetched here. So after calculating this table, we can able to find out the uh, corresponding output. So the output value will be expressed as binary expressions. Applications. So it can be used for communication systems and telephone models, like frequency will be activated multiple number of times so that the telephone networks will be used. And for memory addressing, it can be used for a large number of storage purpose so that it will be communicate to the CPU very easily. And Boolean function generation, because more number of bits has been added if you are using more than 8 is to 1 multiplexer, so that it will be very useful for Boolean function generations. Assessment. An IoT-based smart irrigation system send one control signal to operate different water valves. Which circuit is suitable? So here is a demultiplexer is suitable since it is a distributes one control input to many number of output devices. So if you are using multiplexer means only one output can be generated. So we are using here as multiple number of valves so that we can use this demultiplexer for multiple number of valves. Thank you.